May I have your attention, please? Thank you. Good afternoon, faculty, staff, and fellow engineering science students. I would like to welcome you all to the Energy Systems session of the 14th Engineering Science Education Conference. I'm Yazan Zaman, a first-year engineering science student, and it is indeed a pleasure for me to be here to welcome Mr. Ravi Thuraisingham. It is always interesting to meet a powerful engineer, a dedicated researcher, or a successful entrepreneur, someone like our guest speaker, Mr. Ravi. Mr. Ravi immigrated from Sri Lanka in search of knowledge. He obtained his degree from the Engineering Science and Nuclear Option in '88, and he describes the program as an opportunity that provides a long-lasting foundation for the graduates to pursue pretty much any career. He also holds a master's degree from the Chemical Engineering Department at the University of Toronto. What is extremely valuable about his work is the integration between science and leadership. Only a few years after graduating, he started an American-based solar energy company that is now a $50 million operation with 400 employees. He is the founder and the chairman of Modern Utility. Prior to that, he served as a chief executive officer of Vernacle Solar, the largest Southern California-based solar provider, which encourages the movement towards a sustainable environment. He also conducted research in financial trading risk models, combining the expertise of an engineer and an entrepreneur. Mr. Thuraisingham is a member of the NSI's Board of Advisors, reflecting the true character of a leader and an ambassador to the engineering science program. His strong words still resonate in my ears as he said, "My goal is to expand the Canadian alumni network in the United States and make the engineering science program more valuable to the graduates." May you all please help me welcome Mr. Ravi Thuraisingham.
Thank you. Is that on? Can you hear me? How's that? Can you guys hear me in the back? Perfect. Well, just want to congratulate Christina and the Students Association that put this together. I couldn't organize something like this if my life depended on it. But it's a great job, and give them a hand for what they're doing. So I'm going to talk about, initially about how I change around, and sometimes by luck, sometimes by force of nature or whatever, how I changed around in my career. The major message I want to give is that, when you graduate from engineering science, as brutal as it could be, while you're sitting in their first, second year, go through it because it'll give you wings to fly, confidence to do whatever you want. And you heard some of the other speakers, everybody from being in the medical science to everything, right? So that's just learning to learn is what's going to give you. That's the first thing. The second, so I don't sound like I'm bragging about my background when I'm spending some time explaining how I got here, and I still have a long way to go. The other piece is talking about the electricity industry. It is not your father's industry. In other words, when I graduated, it is changing. I'm going to start with some of the home energy management system that I have two colleagues of mine in the audience that are working with us. We're starting a new business called Modern Utility. We're partnering with one of the players. It will kind of show some of that just to give you an idea. It's what's changing. It's not just Alexa, Nest, and all these things going on in the home automation, but there's a crossover into the energy and the utility side. So with that, let's start. So a few things. I'll talk about, like I said, my background, and then get a little bit more into the what's happening with the grid and what's driving over the years to changing the way the electric grid is operating and is going to be operating. And then talk more about that consumer-driven. So it's going the way the telecom changed, where you were able to just be a service taker to consumers driving how the telecom operates. It's similar things starting to happen in the electric industry. And then some of the other stuff that you've been hearing. Don't ask me about machine learning or artificial intelligence, but I know that's some of the things that are driving the way the electricity business is changing. So a bit about where I came in. I love this quote, by the way. What's not proven, once only imagined. So everything you take for granted today, some crazy guy thought about it as some kind of a startup or some kind of a early days of innovation. So whatever is happening today, and it'll be proven 10 years from now, but you would have lived it thinking that, hey, we were there when this thing was starting up. So how did I come up? So I'm a recovering nuclear engineer. So I graduated in 1988, which is most of you, all of you have never been born by then, even your dad maybe. It was the peak of the nuclear industry. It was the highest paid, most demanding engineering program there. And then it used to be a utility called Ontario Hydro, which was a vertically integrated nuclear to hydro to transmission operation. It was the largest utility in North America. So I started doing research into nuclear safety analysis, and then Ontario Hydro recruited 5 of us. There was 5 of us in our class, into all of us guaranteed jobs. So I dropped out of my PhD and when I worked at Ontario Hydro for about 4 years. But the first year, how many people know about Darlington and Pickering plants? Okay, so these are the nuclear plants. Darlington was the flagship plant, was supposed to come online within 5 years or something. It took 12 years and quadrupled the cost. And when they turned it on, the Canadian reactors, the horizontal fuel rods. So the feeder pipes feed it, unlike there's 2 types of reactors, I won't get into it, is you either enrich the uranium or you enrich the water to make it sustainable fission. The Canadians opted to enrich the water so that if the water spills, the reactor shuts down by itself, versus the US reactors, the enriched uranium, which then leads to potentially be able to use the spin rods to build nuclear bombs and so on. So the Canadian reactors are very unique. Back then when they started it up, there was some kind of a microscopic crack in the fuel. They had no idea what was causing it. So it was the end of the nuclear era in Canada. I was right place at the right time. I got recruited there was like 17 people got recruited into this task force to figure this out. I was on the thermohydraulics team, there was physics team, there's vibration team, trying to figure out what's going on. And we would do cold tests and everything. Long story short, I lived 10 years of nuclear engineering career in 1 year. We were working 17, 18 hours sometimes a day. And then the end result was there's a feeder pipe that comes in called N18. I remember it vividly. The pump impeller spins at 150 hertz. And that pipe happens to, at a certain temperature, resonates. And the fuel rods were just resonating and started cracking. So all that is a year worth of studies. And remember, I was at Darlington when we were doing cold testing, and I did Fourier transform to look at that 150 hertz, and it spiked. We shut the reactor down. It wasn't hot. It was just, in other words, the fuel wasn't lit, but we were just doing temperature runs. We called up the management, and we found the problem. All they had to do was change all the pump impellers to 7 blades, so it became 210 hertz, and that didn't resonate with any of the pipes. I had to think, when they were designing this reactor, took 10 years or so to design them, there had to be a student like you in the back of the room going, hey, what about this resonating frequency? Probably told to shut up and sit down. I'm just saying, but it was an interesting thing. Now, I hope I got that, what happened, recollected properly, but that was my understanding. So I went from there, and at the time, and then I'll get into how I transitioned. I think it'll be interesting because some of you might follow that journey. Others might just stick with 1 or 2 things that you're really good at and never have to take any risk. General Electric has their nuclear head office is in San Jose, California. So they were recruiting at the time that we had, those of you still know the Trade National Treaty, right, where you can, Canadian engineers and vice versa can go work in the States. At the time, I recall, was nuclear engineers and registered nurses were getting fast-tracked to getting green card. So I went down to San Jose, California. Interesting story there. So I'm working as an engineer doing nuclear safety and nuclear design, and that happens to be the General Electric's head office for nuclear. And they were doing budget, And at the time, how many of you know Jack Welch? Never heard of Jack Welch? Wow. So Jack Welch was the well-known CEO who transformed General Electric back in the day when everything was going from metallic stuff to plastic, and he was a plastic engineer, became long-standing, one of the top-performing CEOs of all time. And if you don't know, I mean, I encourage you to read his book, Straight from the Gut, give you an idea of how a fundamental shift. Anyway, so he was there, was the CEO of General Electric. He told the nuclear division to go and give him a new business plan without not assuming they will sell another nuclear reactor again. That's like telling GM, give me a business plan, you can't sell another, you assume you won't sell another car. So that transformed General Electric to do service-based. They went to all the existing nuclear reactors that has safety cushions and then created additional capacity. And that woke me up and saying that's the end of nuclear era in the United States. And do you know there's never been another nuclear reactor ever built since then? So I used that to get my chartered financial analyst. So I would commute back and forth on a train that was an hour and a half, studied for my CFA. How many of you know CFA, Chartered Financial Analyst designation? If you have any inclination in finance or going to Bay Street or Wall Street, you should do that. That's a good indirect way to get your MBA without having to spend $200,000. You know, so that's what I did. I used that to get to Wall Street. I went to Wall Street as a quant, quantitative analyst, designing derivative pricing models and all that. I worked for Merrill Lynch and a number of other players. And then from there, I got tapped to go to Ontario Hydro, Enron. How many people heard of Enron? It was the leading, most innovative company, and then they became most innovative in some kind of a financial, issues with the CFO and other things, and the rest is history. So I worked there 4 years all the way as a trader, all the way to the end. And basically lost everything, had to start all over again. Started getting into retail energy. Retail energy is, if you know it here, there's certain markets, there's 14 states, including Washington, D.C., and all the provinces here, I think, you can buy electricity and natural gas from a competitive player. So I started doing those kind of businesses, thinking that there's consumer innovation will happen, because that was the whole idea of deregulating consumer energy side of things. That had mixed development. In parallel, yet solar and other things started to develop. So I'll get to the last piece of how I got into solar. So I happened to be in Miami working for one of these retail energy businesses, doing well, had a pretty decent recovered position as financially and so on. And somebody came to sell solar energy to my home. I had no idea what solar is or how it even works, and I said, hey, this sounds interesting. So I met the guy a few times at Starbucks and trying to have him explain to me. So these are the, you've seen rooftop solar, and then you have, kind of inverters and stuff, and then you can eliminate almost 70% of your energy, save money. So I used that to understand, hey, this actually applies to California. California has 5 tiers of electricity rates. So the more you use, the more you pay. But when you put solar panels up, it eliminates those tiers. So you got a really asymmetric savings. So it literally, put a model together on the weekends, and then met up with some investors and started a business called American Solar Direct in 2009, 2010. Since then, progressively, and then the industry's been up and down. It's always when you're an entrepreneur, and I've been, since 2009, I've been an entrepreneur. I never worked, other than when we sell a company to a bigger company, we'll work there for a little bit. It's always like 3 step forward, 2 step back, sometimes 4 step back. You just got to keep being in an industry that's changing. So that's what is going on in the retail energy, the electricity industry. So there's a lot of bullet points here. The main takeaway, look at numbers like it's a last major industry to transform. Transportation, telecom, even healthcare, all of these industries been, well along the way in transformation to something new. Electricity industry is now starting to think of it like, shifting into more consumer-driven, innovation-driven, technology-driven transformation. So you're looking at big numbers like, $11 trillion going to be invested over the next, to 2015. And these are, those of you who want more, Bloomberg New Energy does a pretty good assessment of where things are going from a financials and system perspective. So I'm going to get Christian to start a video. This is not, we were working with this particular home energy automation system. There's many like this. Just want to give you an idea with the initial, it's not like all about generating electricity through nuclear and coal-fired plants anymore, even though that's continuing on. There's this consumer product that's starting to come about. It's a short video.
Solar in my home. I've been trying to figure out how to get the most out of my solar investment. I'd like to see how much energy I'm using compared to how much energy my solar panels are producing. What else can I do to lower my energy bill? This is Sense, a small but powerful computer installed in my home electrical panel that connects to my home's Wi-Fi. And this is the Sense app, which lets me monitor my home's energy usage and solar production from my phone, both real-time and over the past days, months, and years. I can also use a web browser to view and download my production and usage data directly. Here on the Now screen, I can get a quick look at what's going on in my home. I can see how much solar I'm generating and compare that with the energy I'm using right now. Over time, Sense uses machine learning to identify individual devices in my home. With Timeline, Sense tells me when the devices turn on and off, how much energy they're using, and how much they're costing me. I didn't realize my AC was on all the time and costing me so much. Might be time for something more efficient. Let's go to the trend screen. Here I can set goals and compare my solar production against my energy use over a period of time. Tapping on the usage card, I can see what time of day I'm producing the most solar, and then figure out if there are things I can do to use more of that solar energy. This tells me that I might want to do my laundry and run the dishwasher between 10 a.m. and 3 p.m. when my solar production is at the highest. I can also view my production and usage trends over weeks, months, billing cycles, and even years. Now I'm saving money and using my solar system more effectively. Navigating back to the goals screen, I can set energy usage and solar production targets for the house, and then get notifications that let me know how I'm tracking over the course of the month towards meeting them. Once Sense has identified a device, I can create a notification to tell me when a device turns on or off, and when it's been on or off for a certain length of time. For example, I can set alerts to tell me if I left the oven on, or if my sump pump is running while we're away on vacation. I can also navigate to the Solar tab to see all of the details of my solar production in one place. There's a solar-specific usage graph and power meter, so I can monitor my production in real time or historically. Go to sense.com to learn more. Sense. See what's up, know what's on.
Again, this is one example we're partnering with, and our lead developer, Karim over there, he has it installed in his house, and if you're interested in seeing the actual app, take a look at it. It's just an example of what's happening in this space with a lot of technology investment coming in. So you can think of it like consumer electronics meeting the boring old energy, and you can actually now know what's each component of your energy consumption, and then you have the ability to manage that, with solar, and then also if you have different tariff rate for time of use, and you can remotely control eventually. So this is like, the good analogy would be, this is like early days of, how many people remember BlackBerry? When it first came out, the first smartphone, all it did was, email, and a lot of early adapters flocked to it, and then who would have thought, it would have come to this. So, Christian, just make sure that I have, time-wise, I still have half an hour, right? Okay. So this is 1987 laptop. So I graduated in 1989, 88, and 89 I finished my master's, at least the experiment part of it, and then started working at Ontario Hydro. And I would lug this is 20 pounds. I lug this thing around back and forth to Markham, run computer, nuclear codes, the safety analysis codes, overnight. It had you had to buy a separate math chip, and then you have all these cameras. So there's no way anybody would imagine iPhone and all these smart devices then. The reason I say this is that a lot of this energy innovations that's going on, including solar, home energy automation, a number of other things that are going on in the edge called grid edge I'll get into, is in my mind is further along than when these things were starting to come into telecom. So the acceleration of adoption into innovation into major grid-based industries is much more rapid than it used to be. So I don't know if you can see it from the back. This is some interesting things I picked up. So the original Apollo computer, 2 megahertz, 2 kilobyte in RAM, it was basically a Nintendo system, 2 Nintendo systems. And then the Cray computer, which is what we were using to design safety analysis for Darlington and all those nuclear systems that's been operating for 30 years, was like one Apple iPhone 4. And that we used to pay $2,500 an hour of computing or some crazy number like that back in the day when you run sequences, different scenarios. And then Samsung Galaxy now is like 4 PlayStations, 5 PlayStations. What did that do? So this kind of innovation drove the telecom adoption, the internet users, right? So similar things happening if you go to the next page with electricity. So the top row, again, sorry I didn't get a chance to redo the chart, but just look at the trend. 1960, you couldn't put a new phone on the grid because AT&T and Bell Canada would say that's going to destabilize our network. So there were competitive players called MCI and Sprint came in. They were competitively attacking the incumbents. And then by 1980, the court ordered AT&T and Bell Canada to be broken up into mama bells and small bells. That's how the first time the telecom was taken away from the controlled monopoly of big bell companies and allowed innovation to happen. And look what happened after that. So in 2000 to now, everything you guys take for granted was driven by what's happening with the consumer products and then changed the grid. So it's no longer what the grid can do for you, what you want from the grid has to change to deliver that for consumers. So look at on the electricity. It's like dark ages, no changes. The full electricity, vertically integrated monopolies control what innovations consumers can have. And they relied on selling reliable electricity, and they've done a great job. The utility industry is very reliable, especially in North America, is incredibly reliable, but it's very expensive to maintain the reliability. So when you switch on this light, literally there's a number of power plants sitting around, standby generators to jump in and provide that real time, right? The speed of light, literally. So that's expensive. So that's the central planning. I'll go into some of the details. And then they started deregulating the wholesale, so you can produce now solar and other things in the utility scale. And then 2000, this is where Enron was innovating, deregulating wholesale and supply and trading of electricity and natural gas. And then look at this cluster. This is where the consumer-driven stuff is starting to happen. So that's going to start changing the way the electricity industry is be driven by products and services. And the grid will have to change to accommodate that. So I won't get into too much of that. This is when you have a central, dispatch stacks of power plants that are way out in Darlington and middle of nowhere, and then you get to see those huge transmission lines bringing the energy to the retail, urban load like Toronto and other areas. The premise behind that was economics of scale. So as you build these bigger and bigger plants, that this gets cheaper and cheaper. But it got to a point where that plateaued out in the 60s. So we call it corporate liposuction. It's now just been it's distributed generation. You produce the energy where it's consumed. It's where the play. All the while, those dots is where the retail costs kept up or kept going up and up and down. So that they didn't experience the cost savings over time because to transmit and distribute the energy to where their loads are became more and more expensive. And this is number of different analysts predicting this is dollar per watt for solar. All right, right now it's about dollar, somewhere in the $1.50 per system. When I started solar in 2009, we were paying about close to $4 a watt, and the efficiency of the panels were maybe a quarter of the efficiency today. The very first application, how many of you knew who published the photovoltaic effect, which is what the physics behind solar generation? Anybody know? It was Einstein. Published it when he published the theory of relativity. Is without getting into too much, basically it's a different coding. The upper level has excess of electron, and the coding below has deficit. And when photons excite the material, and what's in between is semiconductor, transport the electricity. And that semiconductor is no different than your computer chip manufacturing and so on. So that resulted in this cost savings and increasing the capacity of solar panels. The first application was in the space, Apollo and other space exploration early days. And the other interesting one, the first commercial application of it was $100 a watt in the 1970s by the California grow-op manufacturers. So they had to be off the grid, hiding in some mountains to grow their cannabis back in the day. So they would use solar panels to, heat lamps or whatever. So this trend, even though it's kind of plateauing out, but I think there'll be more innovation. You can now produce solar energy cheaper than most other form of energy in a utility scale, and now you have very effective ways to deploy these things in the top of the roof and local communities where it's consumed, called distributed generations. So if you look at this is how the traditional stacks of power, right? You have coal, nuclear, other plants, and then you have standby generators. So the cost component is about 60% of that is generating the electricity. It's about 13% to transmit it over long, from Darlington to substations here. And then one of the most expensive third of that is distributing into each homes and cities. Now, in parallel, what's happening is all these innovation, electric vehicles, solar distributed generation. So this grid was designed to sort of one-way traffic. So that's what's changing. Same thing happened in telecom. It used to be point-to-point network. You guys probably see the old movies where the switchboard operator is actually plugging two lines. And then eventually became mesh network, and that created in different layers. And then you have the software layer that created the internet protocol, and the physical layer is in it. So if one of the data center and lines are broken in telecom, you still get your data because it reroutes through some other mesh. So similar things could potentially, it's going to start to migrate into more of a distributed, multi-directional grid. And it'll take 10, 20 years, who knows. So the major grid edge technology, and I'll get into a little bit more. How am I doing time? Okay. It's the electric vehicle. I think it's here to stay, and now more and more, traditional manufacturers are coming up with. I think Ford F-150 is going to come up with an electric vehicle soon, and I've been in Tesla and others. It's pretty amazing technology, and eventually they'll lead to more of a nimble-sized batteries, sort of like your barbecue tank. You go to Home Depot and switch. I don't know how long, because right now the batteries are big and it's very proprietary. And then distributed generation, we talked about storage. I think storage is a major holy grail. Right now, storage at a utility scale, like a major city and substation level, is very cost effective. But on the vehicles and on a home, it's not very cost effective yet. So the day somebody cracked the code on that, that's going to be a major game changer in the energy industry. And then energy efficiency, because you have all this technology to assess where your energy is being wasted. Like that technology, when you're sleeping at night, it'll tell you what they call a vampire load, what's sucking up energy when you're not actively have your TV and other things on. It's probably a bunch of stuff that's plugged in. So helps you assess those things, and maybe sometimes that's pretty significant. And then demand response is based on that information, you respond how you use your energy. And that's the demand, how you respond to the information you get from these things. And then digitization is everything's become digital, right? So everything from analog to digital, so it's going to be sucking up more computing power, energy. So that's another front that's driving the changes. All these are different careers, different startups, different innovation that's going on in the industry. Okay, so I'm going to speed through this, but this is what's called a grid edge technology. If you Google that, there's a bunch of things written about. I think Professor Kundar talks about it a little bit in her. I saw somebody's lectures or something. But basically, it's a catch-all for everything that's happening at the edge of the electricity and energy consumption, mainly driven by all the other innovations in technology and broadband, iPhone technology. That little device is basically a little iPhone type of computer that reads the signals, learns, and then feeds back and learns through machine learning through a sort of an unsupervised. It takes about 3-4 weeks, and Karen will take it. Initially, it's boring. It doesn't identify a lot of things, but then it slowly learns to a point where it'll tell you when your garage door opened and how long it opened. So that's the electrification. It's a lot more and more, including electric vehicles, uses electricity, and replacing traditional fossil fuel or other type of fuel usage. And then I talked about digitization. A lot of the technologies requires you to do computing and other things. And then decentralization is the distributed generation, not like those big stack and pushing it in one direction, but coming in from the consumer side. Go ahead. It's more of this. So what we're saying, there's 3 major drivers, and these are all, the electric system now has to deal with sort of all full frontal attack from all fronts driven by, future, it's consumer driven, a certain type of application consumers want. They're plugging in their electric vehicles to changing their usage pattern because they now have diagnostic capability to know what's going on in the homes. So that's a consumer application, which is a major shift in the way the electric grid is going to transform. And then, so that's like, your telecom products. And then technology innovation, the grid has to respond, sort of like telecom, they're coming out with 5G network and other things to enable all the things that people are online doing, application from a consumer side. And then same thing on the other side is basically the consumer energy, big data, all these other things that are being innovated around the ability to use telecom and large computing capabilities is bringing on, energy-driven application. So, and it goes hand in hand. Without energy, you couldn't do a lot of these telecom-related, technology-related applications. So, those of you who went to the keynote speaker yesterday, he was talking about how long it takes to, TV to be adapted to 50 million users and stuff like that. So another way to look at it is called the S-curve, right? So the first one, telephone and stove, and in the early days, how long it takes to what percentage of the population to adapt to that. If you look at each innovation, there's radio, and then you got clothing, dryer, AC, microwave, VCR, TV, etc. Believe it or not, what's now proven was only once imagined, right? And the things you take it for granted didn't even exist, even like 70, 80 years ago. But if you notice, the S-curve is much steeper, which means from technology to adaptation is much faster because of the network effect of prior technology with telecom and electric grids coming together to enable everything together. So that's what we're talking about. The grid edge is at this stage. So if you're starting your career, you're in another 10 years, you would see a ton of opportunities that, like if you were when I was in Silicon Valley. By the way, I was brilliantly missed the entire internet boom. I was in Silicon Valley, 93, but I was more jet set on going to Wall Street to do quantitative modeling. Some part of me saying I should have just took a job with Intel or somebody and be some chip tester or something, would have been rest is history. So similar things happening. When a new industry, new things taking off, getting into that, even in any fashion, and especially with your background and studying here, you'll find ways to maximize your career opportunities. Go ahead. So going back to that consumer product, you can't just innovate. You have to innovate, and you have to have capital, and investment money has to come in, and that's what's starting to happen. They're expecting $62 billion by 3-4 years to be invested in grid edge technology, especially these consumer products. And this particular product that we showed just recently did a $18 million series, what's called a secondary round investment from Schneider Electric and these major energy companies that are investing in this new area. So there was an earlier iteration of this. It was called Old Power, and all they did was assess the electric usage, and they'll send you a little brochure saying, hey, you're using energy differently than your neighbor. These are the things we suggest you do. And that became popular, and 100 utilities became a client, and then Oracle ended up buying them for a little over $500 million. So that was the early phase. That was like 5-6 years ago, or maybe more. Now, 51% of the consumers are using some kind of a home device, but I think that includes like Nest and other thermostats, smart thermostats and stuff. 5 million thermostats installed. So this is becoming a real thing. And it's where we think is a lot of the innovation is going to come in, because it's bringing all the other technology innovation into play. We already went through this. I'll skip through this. You guys saw the video, so this again. You can look at Karam's, or again, this is just one of 5 or 6 different top players, but we like this because it's at the right stage, based out of Cambridge, Massachusetts, and we're marketing solar and other things in Massachusetts, so that helps. Essentially, these 2 clamps go in, read the signal non-intrusively, and unsupervised way just learns what's happening. So it's signal processing. So it's based on voice recognition. By the way, one of the project early, when we were in I think final year or something, the 3rd year, we were asked to do voice recognition, do the computing. You got to do a Fourier transform to recognize hello. This is 30 years ago, and we did the math and everything, but we couldn't get the electronics and the computing capability to actually complete the project. And our conclusion was, hell, this is not possible at this point. So can you imagine? So it uses. So in fact, the founder of this came from Carnegie Mellon, and he claims that he was the first to commercialize voice recognition. So it's like, instead of listening to one voice, Siri, and deciphering what you're saying, it's like listening to 20 people in a room and determining who's saying what. That's what this kind of technology to determine what the electric use is. So that's here, and it's commercialized, and you saw how it's applied, and you'll see it in live in Karam's iPhone, that it's here. And then machine learning. I'm not an expert at this, but it learns, it reads the signal, decodes it to see what kind of, it could be an AC. AC has compressor and then a blower. So it has a certain pattern and then does this. You turn on the microwave, it has a certain spike in voltage and so on. And then it goes back and forth, learns. And also learns from all the other installations that are out there on the cloud. So it becomes smarter and smarter as it gets implemented. Thank you.
Thank you so much, Mr. Ravi. This was very inspiring for all of us. So now we're starting the Q&A session. For those of you who have questions, kindly please raise your hands.
Leo.
Go ahead.
Thank you for the talk, Ravi. So you mentioned how we're at the beginning of the S phase of the implementation of grid edge technology, right? So what do you think is preventing grid edge and more specifically residential solar energy from implemented in a really wide scale?
Yeah, it's a very good question. The question was, next time just announce yourself, and that's Leo. He's been my handler. Who's been carrying, walking me around, and thanks for helping me out today. It's basically why isn't this being adapted much faster? I guess two major reasons, probably others. When you have a legacy system, the existing grid and the existing investments, it's unfair to force the utilities to have those investments become stranded. So they slowly allow some of these adaptations to come into play. So there's a little bit of a policy-related things. Otherwise, nationally, you'll mandate, everybody has to allow for solar and these things to be implemented in any utility. So they leave it up to the utilities. As a result of that, like I live in Florida, Miami area, great sun, all that, but it's not a good place for solar because the utility is not as conducive for easily implementing some of these tariff. So one key area that you need is if you're eliminating consumption, your meter has to spin backwards, called net metering. So you get avoided costs of the retail. And not all utilities, regions allow that properly. So that's one reason. The other reason is it's only now the cost curve has come down. It still depends on tax benefits in the US. Here there's some subsidies. All energy has subsidies. The only difference with solar and distributed generation is it's a separate line item. But oil, nuclear, all the other established energy, sub-industry segments have subsidies. So, and you need subsidy to get there. So by 2022 in the US, the tax subsidy is going away. We believe that it's going to be sustained. So that's the other thing. So you need the initial help. So that's why you're starting to get into that S curve. And once that becomes pretty sustainable and you start more people adapting, and then it becomes harder to control it from a policy standpoint, and there may be some kind of a tariff to allow the utilities to recoup their old investment and modernize the grid.
Any more questions?
Richard? Hi,
Hey,
my name is Richard. I'm a first-year ESEC. I just had one quick question. So companies like Tesla that are offering power walls, which are batteries that can store like solar energy used during the day, do you think that that's something that'll help benefit the grid and help it adapt, or do you think that that's something that might make things worse?
It depends on which side you look at it. So it does, in the long run, it's going to help. Because when you have distributed generation, you have locally storing the power through millions of vehicles. Like in Florida, especially when we have a hurricane, we're out power for like weeks sometimes. So this way you plug your car back into your system or local area. So it's going to help from that social benefit. But if you look at it from the utility standpoint, they run on what's called cost plus tariff, right? So they get a certain amount of costs they're allowed to allocate to run their grid and operation. And then the Public Utility Commission allows you to get certain return on that assets. And if they go and modernize the grid and do all kind of fancy stuff, that may not be an allocatable cost, so they have no way to recoup that. So the tariff and the regulatory environment has to change to enable them to get their money. So that's going to start happening. And then you smooth out the cost over 20, 30 years, and then you start to see more innovations in the way the grid. It's already happening in certain areas, but you'll see it very, very rapid prevalent, similar to what happened in telecom. Good question. Yeah.
Hi, Mr. Thuraisingham. My name is Joanna. I'm a second-year ESEC. I had a question. So you went over kind of like the divergent history of energy generation from like hydro to nuclear to now solar. Given your background in the industry, do you see any other sources of energy generation, like new technologies kind of popping off and taking more precedence in the near to 10-ish years future?
I mean, the question is, are there going to be any other generation technology that could come up like how solar did? I think the wind is still pretty viable technology. It may become more micro in the locals. You don't see them on top of the roof or buildings. but some of the innovations happening there. People still talk about improved nuclear and fusion reactors, but I'm not so hopeful because it requires a lot of regulatory, control. People don't want those things in their backyard, but it is something that's being innovated. There's still development going on.
What are your thoughts on commercialized nuclear fusion?
I would say I think technically feasible at some point, but from a society standpoint, whether you'll put it in somewhere in Don Valley Parkway, it's going to be tough. That's part of the reason. I mean, I'm biased because I left the nuclear industry, not because of that, but there's a lot of, it went from technology and innovation to all policy and regulations. And similar to, other industries, the closest one is probably healthcare, where, to bring a drug into the market, it takes 10 years and $1 billion for good reason, because you have to make sure and study it and so on. So similar things, but there is fuel cells, and I haven't seen much, but there's probably a potential because pretty much every home in North America has gas, natural gas pipeline coming into your house for, cooking and whatever. So somehow people figuring out how to use solar and compress the gas, I don't know, something like that, I think you'll start to see maybe. Yeah, go ahead.
Hi, I'm Yang, first year ESEC. I worked in the energy industry over the past 2 summers, and from my perspective, the solar industry in Ontario especially is not progressing as quickly. For example, the Ontario government took out the FIT and microfit program earlier this year. Yeah. So it takes out a lot of the incentive for especially residential customers to upgrade to solar. But I always hear that solar is like the new thing, is up and coming. So I just wanted for you to explain your thoughts to reconcile that.
Yeah, it's a good point. So Ontario, there's 2 ways to incentivize solar. What's called feed-in tariff, so you get a higher price for generating electricity, and it's controlled by the government. Government sets the price. And then the other way is called net metering. So you put it up and your meter spins backward, the utility reads it just like they read your meter, but except at lower usage, and then you pay for the solar separately, right? That net metering is more sustainable because it's based on the natural tariff. Like in California, it's very difficult to go change the tariff, and it's the technology. But what's feed-in tariff, which Ontario had, I think they might have mispriced it earlier on. It was like 80 cents a kilowatt hour when the average price was like 14 cents or something. And that was subsidized by, just government budget. So then they started ratcheting it down. And we were marketing Canadian Solar Direct. And then we kind of said we couldn't wait on different pricing and when the pricing was going to change, so we stopped marketing it here. I think now it's net metering, like the other, but the challenge with net metering in Ontario, you don't have as much sunlight, which is good enough, like, in New York and here, as long as you have southern facing or west facing panels, you pretty much get quite a bit of energy, sunlight. But it's the electric rate. It's not as expensive as in New York, Massachusetts, and California because of the abundance of hydro and nuclear here. So as the cost comes down further, like you saw there, more and more of these markets will come into play. And not to mention the battery, once somebody figures out battery. Incidentally, there's a saying that is, in 1 hour is enough energy from solar beams on the earth to power the earth for the whole year. So that's how much energy. You can't use it all because you need vegetation and all that, but.
Do you think eventually artificial photosynthesis will become a viable option for energy production?
Artificial?
Photosynthesis.
I'm not familiar with that at all, but I don't know. I haven't heard much of it, but it's a good concept, right? Because it's a natural process that's involved in energy. If somebody figures out how to capture it and store it, I would see that, but I haven't seen. Anybody else? Yeah.
Hi, my name's Luke. Thanks for talking to us. When I read your biography, I thought it was really interesting that you had done your CFA. And obviously, as part of your story, you think it's an important part of your journey as well.
Yeah.
When you did it, was it a formality that you had to go through, or did you actually feel like those were skills that you wanted to gain in order to move on to the next?
So yeah, good question. So you said, what was my motive behind doing CFA? I always had some interest in being in financial analysts and investment and stuff like that. But it gives you, if you want to be pure technical, you don't need this, but you should always have this background. Big part of the CFA is learning to analyze financial statements, right? I mean, no matter what you do, you're going to come across that, whether you're investing or so on. Plus investment, what's the background and how the investment world works. So it's really a rigorous 3-year course. And as Angsai, if you got 2 hours a day, you can crank this out. I did each year, one after the other, passed each one. And the 3rd year back in the day was all essays. So imagine writing for 6 hours, 3 hours in the morning, 3 hours in the afternoon. Your hand was cramping. You never write, right, these days. But now with most of it is multiple choice and so on. Yeah, it gives you pretty good. So the learning to take the test is pretty valuable. And now they have, I used to come to, I guess, Windsor, Ontario, where there was there's a lot of, like you can do a 2 or 3 weeks boot camp to kind of cram studying stuff. It's worth, if you got some aspiration, take the first year and see how do you like it. The other thing is now, you heard about, if you've seen the movie Big Short and, all this Wall Street issues that happen with compliance. So a lot of it is now compliance, making sure that the insider trading and other things. So it's pretty interesting stuff. Anybody else?
I have a question.
Yeah.
So now, recognizing that you have co-founded more than 4 companies, which is we highly appreciate that. This indicates that you have a strong leadership quality. So what do you think is the key for leadership? This is more about your experience aspect.
Oh, a lot of dinners and drinking and wine. Well, so one thing I learned, which I shouldn't say I didn't have, but as a good leader, you got to be lazy. So you work hard, and then you teach others to do what you can, what you're able to do, and then you raise those other employees to a higher level, so that you do less, right? So a lot of the leaders, certain times they're I don't know, the nature of their leadership become too controlling and micromanagement. I err on the other side. I give people enough rope to hang themselves. Give them enough leeway to see what their potential is. So that's a key part. Other part is you got to share your vision and constantly talking and interacting, and that's something that I learned a long time ago. That's a key characteristic. Communications.
Any more questions?
Another quick question. I was just wondering, what do you find as some key characteristics you look for when you're hiring students that are potentially right out of university?
Well, Thomas came out of university. I wasn't doing the direct recruiting, but I would say being able to be flexible and dynamic in thinking, not be. We all know, like especially when you guys go start talking to potential employers, they can tell from your background you're technically capable. It's all the other skills. Are you able to work as a team? One of the other thing I'll add with leadership is you have to find what your weakness. So in order to do what I'm doing now, but more than 10 years ago, I could still go down, to the details and model, write spreadsheet model and stuff. I don't like doing that too much, but I had to kind of learn how to be at a much higher level by letting go of technical details, because otherwise you wouldn't be able to think at a bigger scale. So, and you have to find what your weakness is. Maybe it's not technical. Maybe interacting and being more, interacting with others and so on. So you got to find other team members and be comfortable working with people that are opposite or don't have your shared vision, and that's key.
As a up and coming, I guess, professional who wants to enter the energy field, do you think it's more important to focus on the pure theory and power electronics, or is it also important to take a look at policy? And if so, which one is more?
I mean, be cognizant of policy because that drives what's the short-term direction. For example, the U.S. solar policy has been reset where the tax incentive is coming off, stepping down by 2022. So you got to be aware how that's going to impact commercial solar versus residential. But if you're technically, initially, I encourage you to do technical work if that's what you're being trained to do, but then slowly learn all the other skills. I once learned, there's the fellow named, I'm going to probably butcher his last name, Kumar Malavali, or I think he was, there's two things, key innovation that happened in the internet that drove the development of the internet. One is the Cisco system internet switch that early in the Stanford University, the MBA and computer science, or husband and wife, they couldn't transfer data effectively from the two networks. So they came up with this data switching that became part of the internet for data, Cisco system is the technology. There's a similar switching technology with this fellow invented called Brocade communication, which is for data storage. And he once told me, because I had looked at working with him back in the Silicon Valley days, he was working for Motorola as a technical engineer, and he went to work as a salesperson. Not like there's two in technology, there's pure salespeople that go out and hunt down clients and sell, and then it's called sales engineers, people who accompany the sales team, do the technical stuff, including the presentation, explaining the. So I encourage you, to even if that's not what you wanted, that's what he told me one time. He went and worked as a sales engineer for years to understand what the consumers, what your customers want, and that makes you a better engineer. All right, guys.
Any more questions?
Leo.
On the policy side of things, a lot of countries have made promises to completely switch to green energy, like France and China. They've made those promises and goals. What are your thoughts on them? Do you think they're like empty promises, or do you think they have a lot of momentum behind them?
I think those countries have a lot of momentum because it's a national policy. For instance, in the States, that's not so much of a national policy as state level, and it's the way the United States works, right? The individual states have a lot of flexibility in managing certain major industry directions. So I think where there is a integrated national, mainly in Europe, in other countries, I think that's as long as they don't have other conflict with fossil fuel, I think those are real intentions, and as a matter of, I think some countries are already operating. I think Brazil is sometimes they'll operate, mostly renewable and stuff. Yeah.
Any more questions?
All right.
A second question.
Yeah.
So we understand, we actually appreciate the positive effects with the solar energy and how it's helping us to become more sustainable. But there's one major drawback about it, is that it has a high cost of production.
Yeah.
So acknowledging that there's the solution of subsidizing, is there any other solution to actually decrease the cost of production?
So it depends on where you look at it. So if you, in the States, utility scale, all right, large scale, where you can power, a small city size utility scale solar is actually cheaper than other form of energy. But when you get it to distributed generation, you have other factors coming into play, especially with the residential sales and marketing. It's very difficult. People don't wake up wanting solar, right? And maybe in California they do, but still you have to go in and explain to them, and so it's called a push sale, and that's very expensive still. We run sales organizations, it's still, so that plus individual municipalities have different permitting process. Then the utilities, like California had 3 or 4 3 investor-owned utilities and municipalities, and they also have a different process to provision your solar in. So those costs are what we call a soft cost, not the actual hard cost of the technology, is still high. That's what's got to come down. But the technological cost is pretty competitive, even when the subsidies go away. And it's because it's running on that Moore's law, very similar to your computer technology, because it's silicon manufacturing. It's the same way you manufacture your computer chips. Solar is manufactured in a similar type of fashion. Okay.
Thank you. We can only take one more question. Anyone has questions? Any questions? No? Okay. Oh yeah, go ahead.
Do you think there are any ethical drawbacks of potentially going the direction of consumer-driven grid? Like in companies like Sense, the voice recognition, you're quite literally opening windows into people's homes and their lifestyle. And how do you think that companies will deal with the privacy issues?
That's a very good question. What year you're in? What year? Second year. I think it's being solved, or it's being addressed overall. Like if you look at Alexa, Google Home, you hear all these stories of Alexa listening, and they use it for criminal investigation and so on. People do ask, where does my data go? You're right. If your home is being monitored, and when your garage door is being opened, but it's the same thing as everything else. You have on the cloud. You have your full life story on iTunes and Facebook and everything. So it's going to go into that type of realm to manage this through encryption and protection. Feel free to talk to Karam. He's our technical lead, head of software. I think it's an issue, but it's not unlike what's need to be addressed in all other technology. And so it comes to a point where people, evaluate, cost benefit, right? So the benefit probably outlay, potentially somebody stealing your data and saying, okay, well, here's what's going on in your home, unless they have some specific ways to do harm or something. It's a good question, yeah. But it's early adapters usually don't worry too much about that, but it is part of the overall concern. The data is being shared online. All right, thank you very much.
Thank you. On behalf of the faculty, staff, and the students of the Division of Engineering Science, we would like to thank you so much for coming today, Mr. Ravi Thuraisingham. And we would like to award you a memorable gift from the division.
Thank you. Appreciate it. Thank you.